Morning everyone, it's Wasim here from Symetri, and I'd like to thank you for joining us this morning on this Generative Design webinar. I've got my colleague Cheryl on any questions you may have. So basically the agenda is to go through the presentation. We've got 30 minutes or so to go through, and then we're going to allow 10-15 minutes for any questions you may have after the session, but by all means post your questions as you we go through the session. I'm hoping you can hear me. If you've got any questions, if you've got any problems, just raise your hand or put a question in the chat box. Okay, I think we'll just start now. So the first thing, I just want to get an idea what everybody thinks what generative design is, and I've got a quick poll here, and I've got some sort of predefined questions of what I think it may be. Just want to get an idea what you guys think what generative design is. So if you could, if you don't mind, just doing this quick poll. Okay, I'm just about to close the poll. Thanks for voting. Okay, well, thanks very much for the poll. As you can see here, it's shape optimization and topology, and it's a bit like Inventor Shape Generator as well. But it is a lot more than that. But before we actually go through the specifics of generative design, I just wanted to find out if any of you guys have sort of experienced this, where everybody has limits on what they know, predict and evaluate. Even for experienced engineers, typically downstream process is not considered when we're designing something. It may not be true in the most cases, but applying downstream constraints typically it does impact innovation. And finally, I'm sure we have all experienced the pain of late changes. So this is basically, I think everybody, more or less has experienced some of these. And what I'm trying to do here is trying to build a picture up and see where generative design actually will be able to help. Okay, so in brief, generative design is an exploration technology basically. It allows us to generate multiple CAD-ready solutions based on real-world manufacturing constraints and product performance requirements. It works in the cloud, we'll go through that, but just to give you another idea, this was a challenge of a GE bracket, which was basically posted onto GrabCAD, and based on the same requirements, they were all tasked to come with a design which fulfills all the requirements. And as you can see, there were hundreds of designs, all with some done on 3-axis machining, some basically had very high performance, but all with different costs to produce based on materials, process, and other design parameters. And obviously it'd be great that if we engineers within our companies are able to design or create all these options, but it's obviously impossible due to rapid decision-making environments. And this is where generative design can help. Okay, I'm just checking to see if I just had a hand raised by somebody, just checking. Okay. Okay, we're still waiting.
Wes, can you hear me?
Yes, I'm just.
Yeah, it's just a call, sorry.
Ah, okay.
Thanks.
Okay. Thanks, Cheryl. I think we're okay now. Sorry about that, chaps. Okay, I assume you can see my screen now. Okay, so what we can have a look at now is, so what is generative design basically? It's a new way of working. It basically allows one engineer or one human being to work with machine learning algorithms, and with unlimited cloud computing we can generate hundreds and thousands of basically design variations, and then we can choose whichever we like. And this is all done within probably hours, maybe a day, which would otherwise would take us weeks and maybe even months. Okay. So what you see basically here is an example of what generative design can do. The green items are the ones we are going to keep, and the red items are the obstacles which we need to avoid. And then we can apply load and constraints, and we can also determine what method we want to pick: additive manufacturing, milling, or even create any organic shapes. And then the software goes away on the cloud and it creates multiple scenarios, design considerations, and then you spoil for choice. And then you have filters which you can use based on strength, stiffness, mass, cost, and then you can pick and choose which. Basically, I think it ultimately decides what you fancy and what you can make. And what you see here is where we can make these in fabrications, where locations where we can make them. And this is basically all done within the Fusion and in the cloud. And it just goes through. So this is basically, I'm going to go through this on the actual Fusion 360 software to show you how it's done. And this video here towards the end is showing you the manufacturing. And there is the final product. Now obviously, if you look at the design, I don't think anybody would imagine something like that, or even impossible to make. But with 3D printing and additive manufacturing, it's technology is advancing, and it's very, very easy to build these things, and it's been proven. And just to give you an idea, I might just share some examples of what can be achieved with generative design. This is basically a manifold on the from a customer called Innovation Forge. You may have seen this, and what you see on the left hand side is the original design, and on the right is the optimized design with enhanced efficiency with a reduced mass of 75%. Obviously, generative design assumes everybody's interested in design, but I'll go through some more examples, and you'll see that it's not necessarily about weight. It could be simplifying assemblies. So this one is a slightly different example where you've got an assembly. It's all fabricated sheet metal type products, and it's all basically converging 8 components into one part, which is I think another advantage of generative design. Obviously the end product is basically a little bit more exotic than the standard products, but obviously what it shows here is it's 40% lighter and obviously stronger. And this is a similar example as well, where we've taken 50 components in this case, and then basically you have a choice of materials in here as well, which I will show you. There's numerous materials now. I think with Fusion 360 there are specialist materials which we can use also in additive manufacturing. Now this is obviously not the exotic parts you saw previously. This is standard fabrications in sort of factories, and you can see here the original part is about almost over half a ton, 768 kilograms, and the new design is 52 kilograms. So we can use them for normal stuff, if that's the right word. And this is something, another structural shape here, structural framework, which we can also use generative design to be able to optimize the structure. On this picture on the left, we've got almost 26 different frames. It's almost over 1.5 tons. And on the right, we've got almost 14 frames, and we have significantly reduced the frame, and it's a lot stiffer. So this is giving you an idea of what is possible with generative design itself. Okay, now the big question, how we got access to it. I think many of you guys have got access to generative design as part of product design and manufacturing collections. It's now, the product is not called Fusion Ultimate or Fusion Standard. It's just called one product, Fusion 360, and that includes the Generative Design and other products like simulation and also manufacturing, which we are probably going to go through later in the month. The only additional item you need is the cloud credits. And you'll see that in the presentation in a moment, that to submit the job for the explorations, you need 25 credits for every explorations you submit to the cloud. And then once you select a design and you download it, it is basically 100 credits to download a optimized design. Okay, just so now let's jump into Fusion to just give you a brief overview of what Fusion 360 and Generative Design is all about. Okay, just this, before I begin, I'm just making sure that there's no other issues. Okay. Okay, so what we're going to go through here is, let's just have a look at it. So this is basically a product. Now you can see in this example here, we need to basically join the purple items and create some geometry in there. What Fusion allows us to do, if I show you another example just to give you an idea. Now what you see here basically is the red items are the obstacles, and I'll show you how to create these in a moment. And the yellow item is a predefined shape. So what happens is the Generative Design will actually use that as a design envelope and go and create shapes within that envelope, and it doesn't go beyond it. This is a bit like a shape generator. That's one way of doing it, but what Generative Design in Fusion allows us to do is we can start off with a blank canvas. So just to give you an idea, let's go back to here again. I'm just basically going to select these items, and what you can do within Fusion and Generative Design is to pick the items, the green items you saw in the video before. So let's just go through here. So you can see here Generative Design, and then you've got your items called Preserve Geometry, Obstacle Geometry, and Starting Shape. Now in this example here, I'm not going to define the starting shape. I'm basically going to let the software create a shape what it sees fit. Now the only thing with Generative Design is you have to create geometries to preserve. So the preserves, unlike Inventor's shape generator, it doesn't pick faces. It actually will preserve the whole solid. So if let's just go and pick them. So I'm going to pick that item, 4 items in total. And what it's doing here is actually picking the bodies. And if I just hide the pin, you can see the green items are the items the software is going to retain. But that's the start. That's not just that. We need to also determine obstacles. So the obstacles in this case here will be the pin which I've just hidden. So we go and create the obstacles. So this base and the pin. And there's the 2. That's the only things you need to do. And obviously you have something called the edit model. You can go in here and you can start creating items which will be your preserved geometry items, which you may not have in the original CAD model, or you could go and create some obstacles in here as well, in addition to what you have in the original CAD model, whether it's been done inside Fusion or Inventor. So it gives you the ability to create this. Okay, so once you preserve the geometries and the obstacles, we can then go and start putting the design conditions and the criteria. Now one thing I forgot to mention here is inside the study settings, you have a slider. Now what this does, if I was to go and drag it to the left, this is a bit like, if you're familiar with any FE, it creates a 3D mesh. And it'll be a very coarse mesh. What that suggests basically is that the geometry you're going to end up will be pretty coarse. Now if you were to take the slider towards the right hand side here, that will create a very fine mesh, and the geometry created by Generative Design will be a lot finer and smoother, but obviously it will take a little bit longer to generate. Now since I'm not going to run this live, I'll just leave it somewhere here. I've already done this. So that's the only thing which you need to keep an eye on. In the design conditions, we can start creating load. We have fixed loads, fixed constraints, pin constraint, and frictionless constraints. So we'll use the fixed constraint and fix these here. We have gravity load on by default, as you can see here, but we can go and create some more loads. And we have currently some forces, pressures, moments, and bearing loads we can apply. So what we'll do here is, to make life easier, I'm just going to hide the pin. And we're just going to go on ahead and set the faces. And let's just create some load cases here. If I just let's look at a square on. $2,000. Okay, let's make it negative. So that's one load case. Now, in the beauty of Generative Design is you can create multiple load cases, multiple materials, and let it go and create alternative designs based on your boundary conditions and also your materials. So we're going to go and clone a couple of more. And you can see it renames them as well, so you can go and change them. So let's go and edit that one. And we'll just so this is going vertically downwards based on the z-axis. The constraint will stay the same, and just one more. So if I just highlight these, you can see them straight away. There's the two different loads. We'll just do one more. And this one, we'll put a side load on here. Because we're putting a side load here, it's probably going to create some asymmetrical geometry. It won't be symmetrical. So we're going to go in the -x direction. Okay, so I'm happy with the load cases and the boundary conditions. The next thing we can do here is you can minimize the mass, or you can maximize the stiffness and make it very stiff, and you can have a mass target. I think most commonly is to minimize the mass and let the software work out the stiffness. And then the next, now this is something which has been developing from Autodesk, and I think it's been before we had unrestricted, which is basically the organic shapes. Then we have the additive manufacturing, the 3D printing, and then we also now have milling, 3 axes and also 5 axes. So you basically can set these criteria. You can set your tool diameters, shoulder lengths, and head diameters, and it basically gives you a pictorial of what they mean to. I'm going to switch these off for a moment, and I'm going to leave them as unrestricted and additive, for example. And the only thing you need to do here is, because you've got an exclamation mark here, I'm just going to click on it, and basically it's telling me that I've got one of the parts which is invisible. So I'm just going to go and make it visible and click again. It's telling me that I'm ready to basically submit this job. Now what I'm going to do here is I'm just going to go to the next one which has already been submitted. And once it submits it, you can go and go into the Explore option here. So what it's doing now is loading up the previous jobs which were submitted. And you can see here I have got jobs. I think some may already be running, so it's completed, converged. And these are all the jobs which it comes up with. And you can basically have different windows you can select. You can look at property views in here. And that gives you the materials converged. It also gives you the manufacturing method on additive manufacturing, the orientations, whether it's coming the x-axis, y, and z. And the one I like on here is basically the graph. And you can see here it dots them. The color dots basically refer to the different materials. And you can basically pick and choose how you want to display these on the actual graph itself. So this is basically looking at the mass. So you can see here aluminum is basically the lightest, and the one up here is steel. Max displacements. So basically you can pick and choose how you want to do it. So I'm going to go to the mass one here, for example, and if I just highlight that one, and let's have a look at this one. If I just move this one down, so you can start having a look at the geometry itself. So this is basically what it's generated. And you've got your data on your right hand side, and you can also view these. So what it's doing in the background is actually also going through the simulation aspects as well. So you can see the high stress points are the red bits, and the blue bits are basically low stress. So if I just go back and close this one down, let's just open two. So if I just go into display mode here, let's pick, we've got one there. So I'm going to show you something. And then what you can do here, guys, you can start comparing designs. If I just click on it now, and if you click on the whatever image, then it updates the properties on the right hand side. And now if I look at my stress contours, you can see them straight away, which one is more highly stressed. Okay. Now, once you have started going through the investigation or the interrogation, however you want to look at it, let's just pick this one, take that one, and let's just pick this one here. Once you've done that, you can basically go and click on this export button here. I'm just going to click on it just to give you an idea what happens, and that will cost me 100 credits. Now you can see there I'm more or less a millionaire. I've got tons of credits, but obviously we're just part of the channel here. But obviously you need to keep an eye on the green bits here on the credits. So when you download it, 100 credits will get consumed. I didn't show you the other option where it's going to be 25 credits because the job had already run. So if I click on that, it will basically go and download the generative designed or optimized model. Let's have a quick look at what it will actually generate. So if I just go into here, and that is the model it has downloaded and generated. And this is a workable model. You can work on this. So for example, I'm just going to click on this little button here. And there is the complicated surfaces here. And I'm just going to try and modify something here. So you can just pick it. And if I just drag it, you can see you can modify the geometry to however I'm just going to leave it like that for a moment, just to prove that it is modifiable. Finish the form. And there we go, I've got a little bit of a bump in there. And let's do something a little bit simpler than that. Okay, fillets here now. Okay, and then just give it a size of, let's say, 1 millimeter. So what I'm trying to prove here, guys, is that once you download these organic fancy shapes, you can actually modify them with even the surface modeling or the normal 3D CAD modeling stuff. Okay, so I hope that's given you sort of a quick overview of what the generative design is. Pretty reasonably easy interface. Obviously, once you've got the shape is, then obviously you've got to consider it if you want to modify it to your liking. Let's go back to our presentation now. Okay, so just to sort of wrap up the session here, that we have sort of scheduled some sessions around our offices and in Birmingham to give you a chance to try out this generative design hands-on. You can bring, just give you an idea. And what we're hoping for is that you can try it out. And what we have done with some customers is we basically ask them if they have any small assemblies or any parts they would like to try in generative design, and we'll also get them printed as well, just to sort of get them so you can get a feel for it. And so basically the workshop free of charge, so if you're interested and have an idea where you may want to be able to apply it as a pilot scheme with your companies, then you're welcome to join us. Now it's the times for any questions you guys may have, and also you can see on the right hand side, these are also our forthcoming sessions on simulation, which I'll be doing in 2 weeks time, and the rendering and the CAM, which my colleague Cheryl will be doing in June and July. So I'm just going to go quiet and see if I can have a look at the questions, and then I'll answer them as they come in. Okay, one of the questions on here is how much the credits. I think one credit is almost £1, so I think 100 credits is either £90 or £100. I'm not entirely sure, but assume it's £1 a credit. And again, I do apologize about having the poll on for a couple of minutes. Another question I've got there is, if you don't have the collections, yes, you can actually subscribe to Fusion 360 on a monthly basis, which will give you access also to generative design as well. Okay, just one more thing is the generative design is only available as a commercial license. So if anybody out there is from the education establishment, generative design will not be available as part of the education licensing scheme. Okay, well, if you've got any more questions, you'll have we'll send you a link. You've got my details there. I'll be more than happy to answer them. And I would like to thank you very much for attending this session this morning. And thank you very much, guys.